Okay, section 4 of chapter 2 deals with postulates and different ideas that we use in geometry. These are all different characteristics of geometry. They deal with different geometric objects. For example, postulate 5 talks about through any 2 points there exists exactly one line. Inside postulate 5 we can read, I don't know why you're showing up, you should just go away, thank you. Inside postulate 5 we can identify a point and line. Again, those are geometric ideas. Postulates are postulates, theorems, definitions, corollaries. These are all things that have been proven so many times. They've been proven true so many times that we just take them for granted anymore. And as you learn more and more and more, whether it's a theorem, a postulate, a definition, whatever, I do not care if you remember what name it is. Okay, whether postulate 5, postulate 6, whatever. What I do care is that you know what they say. Know that through any 2 points there exists exactly one line. That is very, very important. As we go further into theorems, you're going to learn about perpendicular lines and parallel lines and alternate interior lines and blah, 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 blah. You don't need to remember their names or what theorem numbers they are. Theorem 2.1, theorem 3.5. You don't need to know those. But what they say, you do need to know. Later in this chapter, we're going to deal with proofs. And a proof is nothing more than proving something true and backing up your proof with reasons. Think of it like a jury trial. Okay? You can't convict somebody of something without having proof. You can't prove something is true in math without being able to back it up. And the way you back it up is with statements. Okay? Maybe you use a postulate or a theorem or a definition. And in your proof, you don't have to write postulate 5 as your reason. You can just say, through any 2 points, there exists exactly one line. And we're going to see that later in this chapter. But first, we're going to introduce you to all these that you'll be using to use in a proof. One of them is, through any 2 points, there exists exactly one line. Not too tough. Postulate 6 reads, a line contains at least 2 points. Again, not a really hard idea. In fact, let's take those two ideas, and on the next page, we're going to draw them. Let's draw postulate 5 and postulate 6 right now. Postulate 5 reads, through any 2 points, there exists exactly one line. So, through any 2 points, I need to draw 2 points. There's one. We're going to label it A. Here's a second one. We're going to label it B. There exists exactly one line. So let me get my line out. Come back. And let's make it blue. There. Through any 2 points, there exists one line. Postulate 6 is talking about the same thing, but it says it differently. It says that, it says that on any line, like this, and we need to label it. Let's label it like G. On any line, there exists at least 2 points. So we're going to draw 2 points. Because on this line, G, there are at least 2 points. Not that hard? No, of course not. Let's look at the rest of those postulates on the last page. Postulate 7 says that if 2 lines intersect, then their intersection is exactly 1 point. If 2 lines intersect, then their intersection is exactly 1 point. Let's go to the next page and draw that. If we have 2 lines that intersect, we need to label them. Let's go line X, line Y. Then they should intersect at exactly 1 point. To be able to prove that, we have to be able to identify that 1 point. And there it is, right there. And we're going to label that guy like Z. So, let's go back. Again, we have postulate 7 says that through two lines, x, y, there exists one point, or their intersection is one point, point Z. Let's look at postulate 8 and what it reads. Postulate 8 says that through any three non-collinear points, there exists exactly one plane. Through any three non-collinear, remember non-collinear means they're not on the same line, there exists exactly one plane. So, for postulate 8, I want to draw three non-collinear points. There's one, call that one H. Here's a second one, we'll call it J. And here's a third, we'll call it K. And we're told in postulate 8 that through any three non-collinear points, they can't be on the same line, there exists exactly one plane. So we're going to draw a plane. Oops. There we go. Now we need to label that plane. Let's label it, I don't know, R. Okay? Through any three non-collinear points, there exists exactly one plane. Let's see what postulate 9 says. Postulate 9 says a plane contains at least three non-collinear points. So again, this is talking about the same idea, but it's going in different directions. Postulate 8 said, here's three non-collinear points. A plane goes through them. Postulate 9 says, here's a plane. We need to label it. Let's label it, T. Here's a plane, and inside of it can be three non-collinear points. Let's look at postulate 10. Postulate 10 says that if 2 points lie in a plane, then the line containing them lies in the plane. If 2 points lie in a plane, then the line containing them lies in the plane too. So let's go back. We need our plane. Not like airplane, but a geometric plane. We're given 2 points. I need to label my plane too, by the way. This one's going to be S, plane S. Let me label my points as, P and Q. And now, if 2 points lie in a plane, then the line containing them lies in the plane too. So I want to go get my line. There. If 2 points lie in a plane, then the line containing them lies in the plane also. Now let's go to postulate 11. Postulate 11 reads, if 2 planes intersect, then their intersection is a line. Now this one's a little bit tough because it's very, very three-dimensional. If 2 planes intersect, so I'm going to draw one plane here. There's one plane. And it's going to intersect a second plane. Let's say that second plane goes like this. It's hidden because we can't see it. Or it's dotted because we can't see it. It's hidden behind it. Those 2 planes intersect at that point. Now let me just shade this a little bit so you can see it better. Oh, I don't know why that did that. Oh, I should have been an art teacher. This is beautiful stuff right here. This is poetry in motion, folks. You are witnessing the birth of a phenom. And then last but not least, this part down here. So, we see that we have two planes here. Let's label them real quick. We'll label this one A and this one B. We can see that they intersect on a line. Now that line, we want to make sure is very defined. Okay. It comes through like that. And we want to label that. We'll label it like line, I don't know, W. Two planes intersect, and they intersect on one line. And that's what Postulate 11 says. If you want to see another example of this, look at the wall and the floor. They should intersect on one long continuous line, and that proves Postulate 11. Let's take these 7 different postulates, and now let's go to a real diagram, and let's start using them. Number 1 says all points shown are coplanar. Can you tell that all these points drawn are in the same plane? The answer is yes, you can. In plane P, we can see every point is drawn. Now, if there was a point out here that was labeled R, well, then it would have to be no, because it's clearly not inside plane P. But as far as we know, all these points are inside plane P. Let's look at number 2. Could it be said that angle AHB and angle BHD are a linear pair? Now, if you have to remember, a linear pair is two adjacent angles that are supplements. And if you have to remember again, supplement angles are 180 degrees. So, is it said, or could you say that angle AHB and BHD are 180 degrees, or do they form a straight line? It sure looks like they do. It looks like they form this straight line right here. Well, let's move on. Let's go to number 3. That says AHF and BHD are vertical angles. Remember, vertical angles are two angles that are opposite each other. So we're talking about this angle and this angle. Are those two angles opposite each other? I would say yes, they are. They sure look like it anyway. We could draw a line going from one to the other, and they look like they're the exact same size too. Remember, vertical angles are congruent. Let's go to number 4. Could it be said that points A, H, J, and D are collinear? Collinear, remember, means on the same line. Could it be said that points A, H, J, and D are on the same line? I would say yes, it looks like they are. Looks like they're all on this same line. We could label that line AD, HD, JD, or DA, whatever. But it does look like they're on the same line. What about number 5? Number 5 reads that AD and BF intersect at point H. Now, Postulate 7 says that two lines intersect at exactly one point. Here we have two lines intersecting. Do they intersect at one point? The answer is yes. They intersect at point H. That is an example of taking those postulates and being able to identify them in a drawing or proving them. Okay? We used Postulate 7 here to prove that AD and BF intersect at H. We proved that AHJD are collinear by saying that a line contains at least 2 points. So Postulate 6. And so on and so forth. And you could figure out what other postulate we used dealing with these. Okay? But that's pretty much it. For the homework, you're going to be working with those different postulates from your notes. Nothing too complicated, of course. So let's go ahead and take a look at your homework.